Welcome everyone to new session of Code with Sally. It's our first session in 2025. I'm happy to have you all with me today. And I wish you got the chance, if you missed the previous sessions during the break, to check YouTube. If you're new to the session and this recording, you can find Code with Sally YouTube channel, and you will find we are in the beginner sessions. So you find a playlist here for all the beginner English sessions. You can look into the previous sessions. It's sorted oldest to newest, so you can keep up with what we covered so far. And the reason why I'm saying that, because we start from very basic and we keep adding on. So if you feel like something you're missing or you don't understand, definitely we explained it in the previous sessions. And also feel free to ask any questions you want, whether on Slack or on LinkedIn or during the sessions, and I will try my best to answer you and explain it to you. So today, the topic that we'll start the year with, it's Apex unit test. Unfortunately, it's not a very appealing topic to everyone. A lot of people don't like writing test classes. I don't really enjoy it myself as much. But I understand the importance of Apex unit tests. So whenever I do it, I have to make sure it's done correctly. And I make sure that before I say a piece of code or a class or a trigger to mention it's done as a task, I have to do the unit test for it. And it's very important today that we'll explain the importance of Apex unit test, how to write it, the best practices, what to do or what not to do. And I don't think we'll get the chance to finish everything today. So we'll start today and see how it will go. And if we didn't finish everything today, we'll continue next time. So Apex unit tests. First of all, what's the Apex unit test? So the Apex unit test, it's a way for the developer to test the pieces of the code that we are writing. Pieces of code means I have a utility class with multiple methods. I can test each of those methods alone to make sure that they are working correctly. And same for the triggers or for the trigger handler. I can test small pieces because at the end, the trigger, the utility class, it's not used on its own. In reality, it's used in a controller or in another class. So we don't want to test everything at once. We'll do that. But again, we want as well to focus on testing small pieces to make sure it's working as expected and make sure that the logic we want to do is happening and is executed correctly. And as we will do the unit test for the utility class, we'll do the unit test for the controller in the future as well. So a unit test is the process of testing individual pieces of code, like methods, triggers, classes in isolation. As I said, isolation means we are testing the unit at the utility class, and that's isolated from where the utility class is used or called. We focus on specific code behavior. That means we have a utility that do, for example, addition. We will focus that the addition is happening and the logic is executed correctly. And if I pass two numbers, it will return the sum correctly with no issues. So we ensure that the specific code behaves as expected. And that's why we do it in pieces, or we try to isolate each method or each utility alone to make sure it's behaving the way we want. The benefit, there is a lot of benefit of unit test classes. And unfortunately, when sometimes I ask people why unit test classes are important, the first thing people say, it's required for the deployment and we need to have code coverage. Unfortunately, in my opinion, that's a must or that's a requirement that Salesforce is putting. Yes, but this is not the key benefit of unit test. And that's why sometimes people don't write the Apex testing correctly because their focus is the code coverage and to get the deployment out the door and get it done. But the main benefit of unit testing is very important. It's like it helps you catch issues early, because what I mean by early, like you can test your methods that you have and make sure it's behaving the way it should be as per the requirements. So that means you are catching those while you are writing the test classes. And that means it's during the development, you can find out that, okay, it's not working as expected and you fix it. And that's much easier and lower cost to fix rather than waiting, for example, to go to QA or full test, UAT testing, or even go to production, because each step along the way, if it needs testing, that needs more work, more team members involved to make sure it's working as expected. So it helps us catch issues early if written correctly. If written correctly means we have asserts and we double check that the code executed correctly and not just calling methods to have code coverage and that's it. And we'll look into that correctly in depth together as well. The other benefit, it prevent code from breaking. Why? Because in any project and any team, you are not working alone. You will have other team members and maybe other company or another vendor working on the same code base. And maybe you do something and it's working and you deploy it and you deliver it. But someone doesn't know your code and come tomorrow to do a change or add a functionality, their code work correctly, but they may break an existing code that used to work. How can we catch that? We can catch that with unit testing, because sometimes, okay, we will say QA people will be testing and they can figure this out. Sometimes it's not related, like you modify a utility method, but it's used across different business or different functionalities. And QA is focused on one functionality to test it. They will miss that it broke the other one. They are just focused on this area and they may miss the other business unit that is using the same method. So if we have a proper unit test classes that is written, that will help us with catching those issues. That if your code is written and you have proper test classes, that's a safety for you. Safety from others who can modify your code or modify something your code is using and cause that your code is breaking. For example, you may have a selector class where you select a specific fields from an object and you are using those fields, and someone come and say, okay, I don't need this in the so-called anymore. I will remove it because my method doesn't need this field, and they can remove it. And your code and their code is using the same method. Their code will work because they don't need this field anymore, but your code will fail that you're not selecting all the fields now. And if you have a unit test for your code, we can catch that, and the exception will happen when they run the test classes and they will revert the change again. So it's very important to catch errors. It's very important to keep the code working and keep validating that nothing changed to break it. And um, something we'll talk about, like we have to test not just the happy scenario or the positive scenarios where the code takes expected inputs and do the expected behavior for the output. Sometimes, and it's recommended as well, to do the negative scenarios. Negative scenarios means like if a method expect like two positive numbers, maybe I will pass one positive and one negative and see how it will behave. And if it will through a proper error message saying like the two values need to be positive, please review your numbers and try again. Or we'll have an unhandled exception and it will pop to the user with an ugly message. Like that's the kind of negative scenario. So unit test classes, if written like in the right way, it will help you solve all those problems, catch issues early, can serve like kind of like a regression testing to make sure everything is working. It can serve to test positive and negative scenarios, and that sometimes that's useful because even QA won't keep testing all the positive, all the negative scenarios every time they test. They will, when they do the regression, they pick and choose the most important scenarios to test. But your unit test, if written properly, it can be testing more scenarios, and it will keep running every time we run the test class. Any questions so far or concerns? Okay, we don't have questions in the chat, so I think we're good. So that's why, like, again, I keep telling people I will take my time explaining why unit testing is important. And the reason why I like highlight this so much, because people when come to Apex unit test, they rush it and sometimes they focus on the code coverage more than the quality of the testing. And they ignore the benefits, even if it's more time consuming or it takes more time. With the practice and repetition, you will be faster writing unit test classes. And if you understand the benefits, you will write better unit test classes as well. Okay, let's move on then. So next slides, like we will talk about several steps that we want to learn, like not steps, but topics that we want to cover today. And one of them definitely is how to write the test class. But is it just about how to write the test classes and using the test notation for the methods and the classes? The answer is no. It's not just about how to write the test class. There is also how to prepare the data, because we'll explain this more, but like when you write unit test class, some people do the mistake that they rely on the org data. And that's a huge no, and it's a very big red flag that you should not be doing. And the reason why, because if you rely on data, what if this data doesn't exist in another org? Your test class will fail in the other org, and you cannot rely on data or change data or rely on real data while you're working in real life projects. So we have to learn together how you can prepare the data that you'll be using for the test classes that you're working with, like how to create accounts, how to create contacts, or if you're a class is relying on creating custom objects, you have to do that. Or in the future, when we learn about Visual Force pages, maybe you need to pass what's the Visual Force page you are working with. If there is parameters, you will pass it as well. So it's very important not to narrow like your focus on just the test classes. It's more than that. It's how to prepare the data as well. And when we will talk in the future about integration as well, how we can like mock the data, because we cannot consume external API while working with test classes. So it's way more than just writing the test class or the test method. The third is how to run it. There is different ways to run. There is how to validate that the logic is working, how to make sure after running that you're not just relying on code coverage, you're also doing asserts and checking the results, how to check the code coverage. And what I love to do as well when I get a failure, how to debug it. So I can go through the steps step by step in Visual Studio Code and see how my code is behaving, because that helps me easily to figure out which step, for example, didn't go the way I was expecting it to go. So again, those are topics that we want to learn, and don't focus just on the test class. Any questions here? Okay, so we are good. Let's move to the next slide. So preparing the data, like this, the first part that I will just highlight it, and then we'll go through how to write test classes. As I said, like why we write test data, we want to isolate the test from the data in the org. So we don't want to rely on record or an account with a certain name, and you go and try to select it in another org and you don't find it and it fails. We make sure that the test classes are independent from the data and from real data. And test cases as well are independent. Like I can create for one test method an account with name Code with Sally, because I need an account with that name. And in another case, I want to create another account. It doesn't matter the name, but it matters that it's IT industry. So it can like separate any dependencies that I don't need to have an account to name Code with Sally in my org, and I don't need to have an account with the IT industry to run it. That makes it more independent, and each test case can have its own data as well. We can mock different scenarios, positive and negative. We can make sure, for example, if we have a calculator and we do a division, we can like simulate that we are dividing by 0, so we get an exception and an error, and see how the code will handle it. So it helps us give us more flexibility to test more scenarios that serve the positive and negative testing that we need to run as well. There is different ways of how we can prepare test data. Part of it is when you write test methods, you can create your own data, and we'll see how we will do that. And that's the simplest way. We'll start with it. You can move, instead of like each test method to have its own data, we'll move that into test setup, and that will make your life easier if you have to create, let's say, an account and a contact for 10 test methods. Instead of having those in each 10 methods, you can have it in the test setup done once, and we'll see how that will go. You can have reusable test factory, and that's something we'll see how we can write it. It's simply a utility class where you will have methods that create certain data for you. And the reason why we do the test data factory to enable reusability, because maybe you will have a Visual Force page controller that needs an account and contact created, and you need to test it. And another test class for contact creation for a trigger, and that needs an account and a contact as well. So instead of repeating over and over your account and contact creation, you can have it in a test factory and call it from multiple test classes. Are those the only ways to prepare test data? The answer is no. There is one other ways to do it, more advanced. We'll cover it in the future. As an example, you can prepare CSV files with multiple records to cover different scenarios for contacts and accounts, and then load it when you come to test classes and use the CSV files. You put it in static resources, but for the beginner sessions, we'll rely on those only, and we'll see it in a bit together, how we will do each of them. And the main topic here is how you can write the unit test class in Apex. So test classes validates your code for Apex that they are working as expected. So there is several steps you have to follow when you're writing your test class to make sure it's working and it's doing what you need it to do. So let's see here an example first. I prepared here a math utility. Let me here, I'll go clear this. So we do it together. The first thing, let's see what we are trying to test. So we have here a class math utility, and this is just an example to learn together. So it's very simple, but what it does, we have one method here that takes a list of numbers and calculate the sum for them. So it loops through the list of number, do the sum, and return the sum as a value. Another overload for the method, same name, and it takes just two numbers, do the calculation. And here I just did an example that you can reuse it. This is a generic that takes a list, but maybe you have two numbers. So simply you call the same method, but you create a list with these two numbers and use it instead of writing the code again to do number one plus number two. Here we have a method to divide numbers. It takes number 1 and number 2, and it checks if number 2 is 0, it threw an exception, and we return the result. Another one for subtracting two numbers. So it just is simple utility class. And if you remember, we spoke about when we learned about methods, we said the static and object-oriented. We said the static is the methods that you will call using the class and not an object from the class. So here, because I don't rely on any properties in the math utility class, and I don't need like an instance from it, so I have this as a utility and the methods are static. So we want to, first step, we said first step is use the isTest annotation to define the test class and method. So what do? Is that we create a class, and at the top of the class, we put as is test. And the reason that's a way to let the compiler and let Salesforce knows that, okay, math utility test is a testing class. Don't count it with you for the code coverage. Don't give me a code coverage percentage for it. This is a testing class. So the name, it's the same, like we have public and class. For me, if it's a preference, it's not a requirement. You can name it ABC testing or testing class 1, totally up to you. But for me, as a preference, I name it as math utility, the same class that I'm trying to test, and I add at the end test, just to make it like a bit the naming convention, or when they are ordered together, I have the class and the testing class for it next to each other. So that's the first thing, that I have the isTest annotation for the test class. The second is the method. So the method as well, I need to say that it's a testing method. So I will use the isTest as well here. And I will create the first method, static, void, and then what are we testing? So the first method, I will be writing a test class for it, is adding the numbers, this one, the two numbers. So you can name it again, anything you want, but I prefer to call it something test addition. So we are testing the addition, for example, or test adding two numbers, whatever the name that you want to give. So you know it's related to which method, and make it like the name meaningful. I know people sometimes name it test method 1, test method 2. Nothing will stop you from doing that, but if you keep the names meaningful, that would be great. So that's the first step that you do when you write a test class. The annotation for the class, the annotation for the test method. Second is preparing the data using data factory, or creating your own data inside, or creating the data you want inside the test. Here, because we have a simple method, so all what we need to prepare is the two numbers that we are trying to test. So here, preparing data, I can have here define integer number 1, and I can put here 5, and for example, integer number 2, and I can have here, this is at 10. Again, in real life, if you have a test utility for numbers, you can have the data in that format, because you make up the numbers. But for example, if you are testing contact update, so you need to have the data will be in a form of creating contact instead of just defining the numbers. So that's the second step that we did here. We finished the annotation, we finished the data preparation. The third step would be executing the code that you want to test. So here, the next step is execute code you want to test. Here, what do we want to test is the math utility. So I will take here the class name, because it's a utility, and the method is static. So the method name here, and I will pass number 1 and number 2. So if you remember, like in the past, we were always doing um, like execute anonymous, and we were creating the values and we are executing the method. So the same as if like you're executing the method or your utility from the execute anonymous, but you do it from the Apex class, from the unit test. And the last thing is verify that the data and the expected results are correct. So here that will take us to the validation step. And here I will show you 2 ways that we will work with it. One way, people are very like familiar with that, and a lot of people use it because that's the old method. We use System.Assert equal, and it takes like what is the expected for me, because I know I'm passing 5 and 10. The expected is 15. And then what's the actual result? I have here to return this, like this method will return a result for me. So I will have to enter here integer, and what's the result? So the result from the method we are trying to test. And here, this is a message that will show to the user, which is yourself, when you are trying to run the Apex class. If it fails, it will tell you the additional result should be 15 if the value wasn't correct. So that's what the steps are. Like, prepare the data or create your data, regardless how you will create the data. You make sure you execute the logic that you want to do, and finally do the validation here. But for the validation, now Salesforce, not very recent, but they introduced something new called the Assert class. So that's something you keep in mind. We want to be using the Assert class instead of System.Assert equal. Assert is assert.r equal. This is the method in the Assert class to be used. It takes the same. Let me open the class for you here. So if I open the class here, you'll find here r equal, the method that we are trying to execute or to use for the assertion or for the validation. It's the 2 first. One is the expected, what's the actual from running the method, and the string. And the string you'll see here, this is optional. You can pass it or not. It's the custom message to return as an error message if the assertion or the validation didn't happen correctly. So this is how we do it now. And the reason why I'm showing you both, I have a slide. Next slide will show you the old way to do it with the System.Assert equal or not equal, and so on, and the one with the new class. The reason is because a lot of developers still are using the syntax. So I don't want you to be confused if you see it. And existing code that was there before the Assert class appeared will still have it. So it's good to know when you read it, how to read it, and don't be confused, and to know the equivalent, like the System.Assert equal is the same as assert.r equal, because you can start refactoring existing code to use the Assert class. So that's how you can write the class or the test method. You start with the annotation for the class and the method. Then you prepare in each method, you prepare the data, you execute the code you want to test, and you do the assertion. Now we tested only the add number. We want to test the divide as well. So let's write the test divide with together. So let's see it together here. First, I will do the annotation. Second, I will define the signature of my method, static, void, test, division, for example. And I want to prepare data. I want here, execute code we want to test, and I want to do the validation. So here, someone can tell me how can I prepare my data for the division method? The division method, this is how it's working. It expects two numbers and it will check if number two is 0 or not and do the division for you. So in that context of this method, how I can prepare the data. Someone wants to write it in the chat or tell me? Yes, Ryan.
Let's see, it's been too long and I've missed out on most of the beginning ones, but is it double? And then you probably want to use a different, maybe dub one
Okay.
equals.
I will just stop you here. Method, the
Okay.
method expects
Oh, yeah, you're passing in an integer. I see.
to
Okay.
integer, but let's change this to decimal or double, because the division wouldn't be always like a whole
Yeah.
number.
Well, I was
So
thinking that the return would probably be a decimal, but what we'd
yeah.
pass in would not necessarily be, but then we should just use decimal throughout, right?
Uh, Again, if
Or else do
writing.
we have to cast it? I don't know.
Yes, yes. Again, it's based on the requirements. Like if you have a requirement that you want to have a method that takes any number, double or like a whole number or decimal and do the division. So definitely when you were writing the utility, you will have it here as not integer, so you don't have to typecast it and to allow division of decimal. Here, when I wrote this, I didn't do it as a decimal, but I can change it here. Those are decimal, but definitely the return type shouldn't be an integer because it's not always like divisible. So, okay, let's do here decimal, uh, decimal value one. And for example, what do you want to do? Like 10, it's integer and decimal value 2 and 2, for example. So it's easy for us when we do the assertion. For the execute, and that's a good example as well. Like um, if I had it here as an integer, the return type, and I will try to divide and return, or I just return the part of the integer, my test class will fail if I'm expecting to return 10.5 as a result or 3.2. So it's something good to keep in mind. That's one scenario. For example, you may did a mistake as a developer when you are writing the class in the first place by choosing the wrong um, data type to pass or return, and test classes can help you figure this out as well. So we have here prepared the data for the execution. Someone or Ryan, can you tell me what should I write?
Uh, I guess it'd be pretty similar to above. It would be a
Let's take
decimal result. Yeah.
decimal results, yes. And
And then whatever our division math utility is.
divide numbers. And you will pass
Yeah.
the decimal number value 1 and 2, right?
Sounds right.
Okay. And then we'll do the validation. Do you want to do the validation too?
Yeah. Now is our assert still our equal?
Okay.
Or does it change for, I guess, okay. I guess it
It's
doesn't
same.
change.
It's what's the value you are expecting and what happened.
Okay. So we'd put 5 and then result
Correct.
and another comma and then division result should be 5 for
Okay.
text for the
Division
user.
value should be
Or yeah.
okay. Yeah, that's good. So now we did the divide as well, and we'll stop it like this. I want test. I can test as well. We are not testing yet to divide by 0, and we didn't test the subtract, but I want to show you how you can figure out what you're missing if we stop it like that here. But again, like we will be following the same, like we did the annotation, we prepare the data, we execute the logic that we want, and we did the assertion. Some people ignore this part, the assertion. And that's very, very critical because otherwise, if the for any reason the method is returning instead of 5, 8, you don't have anything that verify it for you. You are just calling it for the sake of code coverage and that's it. But if you have the assert, that will make sure that the code got executed and behaved the right way. Okay, so here we covered like the how to write it, how to prepare the data, how to use the assert. And what I want you to do uh, offline, I paste for you here the assert class. Take a look on it because it have different, it has a lot of classes and different ways to test values. And we'll look briefly about it in the next slide as well. So that's how to write the unit test classes or to check the values. It's very slow. Sorry for that. I move to the next slide. Okay, yeah, the next slide here, I just wanted to give you an idea of the beauty of a certain class and why it's better than using the old method. You won't feel the difference with our equal because it's moved from system.assert equal to are equal. So you will feel it's the same. And the same for are not equal. You're checking on purpose, they are not equal. Here, if a condition is true, that's something in terms of readability, you will feel that the assert class is better because in the olds, you will do system.assert in condition and your condition should be true or false. And when you read it and developers were using it, like sometimes they get confused. But if you have something that you want to evaluate if it was true with the assert, you will do assert dot is true, and that's more readable, or assert dot is false. In the old way, we're doing system dot assert and the opposite of the condition, which will be the false. So reading something like that, it's harder than reading this. This is more user friendly. Same when we were checking null, we were checking if the object equal null or not equal null. But now with the assert, we have a method for assert is null or assert is not null, and you pass the value. So for example, you're trying to get or retrieve an account from a query and based on a certain condition, and you are checking if the account is null or a set is null or a map is null. So you can have, you want to check based on a certain action if certain variables are null or not. So now with the assert, this is more user friendly. We'll try to gather the assert.fail, but again, sometimes you want, for example, if there is an exception, you want it to fail, and to give the user, like, if there is something that happened to fail the test method, and in the past we were just using assert false and give the message, so you are failing the test intentionally. But now there is assert.fail, and we'll try this together. And there is extra methods like checking an instance of type. If you attended with me, like the S objects and generic S objects, sometimes you want to double check the S objective is which type. So again, the instance of you can help you do that. And that's something doesn't have like a similarity in the old way to do things. So those this comparison, it's more like don't feel overwhelmed. You are not supposed to learn or memorize it all. I can send the screenshot on the Slack channel after if we are done. But it's more, you have here the methods, you have how it works, why it works, even with examples. So whenever you're writing the test class, I would say it's a good idea to open the assert and see what you are trying to do has a method to do it or not. And it's good to know the equivalent, because if old code has something like that, it will be harder for you to read. And if you want to refactor the codes, you know, like the equivalent to use. So any questions so far? Good. Okay. So let's go back and I will write another scenario for the fail so you can see it, what it means. So I want to, now when we did the testing, we test the divide, but I passed, I would say, positive scenario that you passed a 10 and a 2. A negative scenario is when you are expecting to pass invalid data. And in that case, if I'm passing number 2 as a 0, that's an invalid. So I want to test a negative scenario and use the assert.fail in that scenario too. So let's see it together here. Again, I will start with is test, and I will say static void test division by 0, for example. So I want to divide by 0 and test it. I would take here the prepare data, the second number in that case, because I want a negative scenario or I want it to fail, I pass it as 0. And then I want to execute my code. But my code, when I will execute it, it will give me an exception because I'm throwing a legal argument exception here. So what we will do is we'll use a try and catch. So I will have a try and catch here because I know that my code will throw an exception. And I will do here, I will execute the logic that I want, which is this one, the divide by 0. If the code came here, like if I have, for example, system.debug and I print the result, and is that the expected behavior? Like, do you expect if I pass number 2 as a 0, do you expect that this debug statement will be printed or no? So what will happen is I will call divide numbers. I'm calling divide numbers with number 2 is 0. So it will go to the if statement. It will find the number is 0 and it will throw an exception. So an exception will be thrown here. So when the exception will be thrown, will I go to the catch or the code as the debug statement will be executed?
You'd catch it, right?
We'll catch it. Exactly. So we'll catch it. So the happy scenario for me is that we go here. So the happy scenario, and that's what I would consider the test passed successfully. I would say here are equal. And here I can say, let me get this message here. I can say that I have a message cannot divide by 0 because this is the message that I put here. So if my scenario worked as expected, the exception should be thrown here, the catch should be executed, and the exception here would be equal to the message that I have. Okay, if for any reason my logic come back and we don't have an exception, if I reach the debug statement and I don't go to the exception, that means my scenario is wrong. So here, this is where we'll use assert.fail. We said assert.fail. Let me show it to you. This one immediately return a fatal error that caused the code execution to halt. Like I'm intentionally failing the test class. I want to tell whoever is trying to run the test class, hey, this should not have happened, and we were expecting an exception to occur and to have an assert dot equal are equal here execution. So I will say here expected an exception for division by 0. Okay. So this is just, and I don't need the debug statement, but that means if we reach this line, that means the exception didn't happen, and that means the code didn't execute the way it is. So let me show you. Let's run together how to run the test classes with another slide, but I want to show you the different ways and how this will behave. So I will show you one way now how to run the test class and to show you different scenarios, and later on we'll learn more about the other ways. Okay, this is another count trigger. Just remove this. Okay, let me go here. We go to test, new run, and I say I want to run the math utility, and you can choose. I want to run test addition or test division or test division by 0. Let's run all three, and you hit run. Then you open the tab here, test, and you will find that the math utility, it has like a check mark, and it tells you that the 3 of them were executed correctly. Let me show you, for example, how this is helpful. Like if someone later on came back and instead of adding, did a minus here, like change this by mistake. So another developer, after you implemented your logic and you delivered and everything was working fine. If they run the methods again, let's run it only, the first one. If I run it, it didn't save, sorry. This one didn't save yet. Let's save it first. Okay, now it's saved. So if I run it again, new run, test, and addition one, it will show you a cross here, wrong, it didn't work. And it will tell you that assertion failed. Addition results should be 15. This is the message that we are adding here. Addition results should be 15. So we are telling that the value should be, but we got minus 15 because someone by mistake changed the number, the sign from positive to negative. So again, it's important. It keep your code safe. You know, it's working, you delivered. If someone changed something, they will show. So that's an example how this would behave. Another example were the negative scenario, for example, and how the assert fail will execute. Now, what is happening? That when I run this, again, it run 10 and 0. It will go here. It checked that the number is 0. It will throw an exception. So we'll go to the catch, and the assert here will be fine because the message was right. Let's try first to add a message to the message here 1 to show that the message will fail, that the message is not equal. So here, test, and I will test the last one, run. And I see here, it's failed. And I will see that assertion failed, expected division by 0 error message. Expected, that's the value, but what we returned has the 1 at the end. So this will be not executed correctly, and the assert will fail here if the message didn't match. Okay, what if, for example, here, someone return, for example, a hard-coded 10. It's not realistic and it's not real life scenario, but it just to show you that when I pass the number 2, we are expecting to have an exception, but it didn't happen. Will we get this error or we'll get this error? Any guesses?
Ooh. Um,
Sorry, Ryan, I didn't hear you.
I'm not sure.
Okay,
I
so
guess we'll have to run it and find out.
okay, but I want you to get used to trying to debug it mentally. So what is happening here? I call divide numbers. What will happen here? I'm returning in a 10. So will we go to the catch, or after calling line 39, result will have 10 and will continue execution? We are returning 10. So
Right, and we weren't expecting.
we were expecting an exception, but actually we
Yeah.
get the 10, and then the line 40 will be executed. So my expectation before running that this is the error we are getting. We are intentionally failing because we were expecting an exception. Let's try it together.
So it's because an error happened, but that specific exception wasn't what was caught. Is that so? If
Here,
there were other errors, then they don't get caught by that specific exception. Is that why we're?
why we are doing the catch here, we are doing it because when you coded your method, you said, okay, I want for safety to check that the number 2, if it's 0, I will throw an exception that it cannot be divided by 0 because otherwise the division will fail. But here you are like doing an extra check in your code and specifically sending this error message as an exception. So,
Right. I guess what I was asking was
mm,
there can be different if it could have different exceptions, and
yes.
it's because this specific exception wasn't caught is why we'll have a problem.
Yes. So if you have another exception and your exception, you will go to the catch, but your assert in that case will fail. That this is not the error that failed it. So for example, you threw intentionally another error, or someone you were throwing another type or another error message, or for example, you reach a DML exception before reaching the division, and it caused another DML exception. So when it comes here, it won't be an exception for DML. So it will throw a assert fail as well because the error message wasn't the same. So here it's like you know what the data you are passing, and if everything works fine, you are expecting specifically this error message. If you don't receive this error message, you should fail. And if you receive another message, error message, that means something else you didn't think
Mhm.
of is failing, and that's why we would fail the assert here. We are
So
specifically expecting this.
so will we get line 40 no matter what that other error was? Like if we had a DML, we would still get 40 because we didn't get the specific one, or we would get the DML error.
No, you will get the failure will be in this line if
Okay,
you get
so
an
it would be
exception.
in that line
Yeah. If for
if there's
any
any
reason,
exception, but we're
yeah,
short circuiting the exception with the return. Okay,
yeah. If for
thank
any,
you.
like if your division here got a DML exception and that was like thrown before the illegal argument exception, you would come here and it will fail. I will show it to you. Let's finish this example and I will just try to mimic it in another way. So here we are just returning 10. So we are assuming that there is no exception happening. So if I try to run in that case, I'm expecting if I pass number 2, I will get you cannot divide by 0. So if this doesn't happen, the test class should fail as well. So I'm failing this here, but it's failing with the line saying expected an exception for division by 0, and it didn't happen. So if it goes to line 40, that's why we do the fail, because we are expecting an exception, but it didn't happen. And that's why here we are saying in the past, instead of fail, we were doing System.Assert false. We are saying that it's like as if it's condition and it's false, it's not true, and give me this error message. So it's harder to read. But if you have in the code assert.fail, this is easier for you to read.
Yeah, it's more explicit.
Yes. So that's why if we reach line 40 and we are passing the second number as 0, we should not reach this line no matter what, if your code is working as expected. So that's why we are failing it here. The other scenario you were talking about, but I cannot do another type, but I will say here, I will through, uh, if, for example, we are passing 10, if number one, if number one will equal 10, I threw here DML exception. I will say DML exception just to mimic as if an exception happened. Here I'm throwing an exception myself, so it's not a DML. But here in that scenario, you can assume this was a DML exception that happened in the code. Which one will, which assert will try to execute, 40 or 42?
So it would be 40, no, I guess it would be 42 that would try to execute because there was an
Makes sense.
exception.
Correct. So here we did an exception to mimic as if we have a DML. It's different method message. So if I try to execute now here, I will get an error. This is divided by 0. So let's execute it. It failed. And it will tell me in that case that the assertion failed because I was expecting a message to say division by 0, but we got DML exception. And
Okay, makes so much sense. Thank you, because
you know,
that way you can track other errors.
you can track, and in that case, for example, that you are not supposed to get a DML exception if your code was working fine. But if it's failing or start to failing for a DML exception here, that means, or another governor limit, that means something is wrong and you need to check the code, or if someone did a change in the code, what's the change? Maybe they did a DML inside a for loop, and no one picked it, for example, in the code review, and with bulk check or something, it's failing. So if your code is working as expected, we should expect just this error message. And that's the benefit or the beauty of like having a negative scenario test. Like you're still testing the negative or the exception, but you know that this is an expected message or expected exception, the input that will cause it. And this is the exception that happened. If another exception happens, then your assert here will fail and you have to investigate further. If your code doesn't fail and you were expecting to fail because you have invalid data, that means something as well is wrong. So that's why we are using the assert.fail in this case. So that's the benefit of unit test classes. It's not just for testing positive or for code coverage. It's for different scenarios and different combination to make sure the code is working as expected for positive and negative as well. And this is just to give you an idea like why the assert is better. And at the same time, if you have existing code that has the old way, you can convert it to the new way as well. I posted in the chat after we are done on Slack. So again, we had a quick look how to run the unit test so we can play with it and see the different ways. Next time, we'll see the other ways. We'll see how we can do it in Visual Studio Code. I'll give you a hint that you can do it in CLI, like with the terminal, if you need it, just for advanced, like sneak peek about it. And we'll see how we can debug it as well. And we'll take it further from there. We don't want to rush the unit test and how to write it and the benefit of doing it correctly and nicely, because as you can see, like you can quickly before I go, but for example, here, if I have an exception, and if you don't do the assert, for example, here, to check that the error, if you don't do the assert and you try to run your code, your test method won't fail anymore. So if I do here, we are throwing another exception, it should fail, but actually it will succeed. It tells you here completed and passed and everything, no errors, nothing. So that's the problem, like with having it's here check mark. So if you don't have the asserts, you can have false positive that things are passed and working as expected, but in reality, it's not working as expected. So it's very important to make sure you are always having the is test notation, prepare data, run the code, and the most important is the assertion or the validation. Otherwise, your code may not be working as expected, but because you don't have the assert, it will pass and you won't know. Any questions so far? I'm sorry we are over with 6 minutes. I know people needs to go back to work. So I'm sorry, but like if anyone has a quick question or something, I'm available for you. Okay, no questions in the chat. Okay, again, Ryan, do you have a question?
I was just coming off to say thank you. Sorry.
No, it's okay. It's okay. So yeah, thank you so much for attending and for taking the lunch break with me today. Next week we'll continue our journey with the Apex test. I hope today was a useful session for you, and thank you for watching if you're watching offline. And I will see you next Thursday.